Hi, welcome to this video that shows how to map EtherCAT PDO messages to pass values between PLC program variables and control techniques drives parameters. In this demonstration, what we're going to do is we're going to read from parameter 2021 in the drive. That value is going to be read by an input PDO. The value is then going to be passed to a program variable called from drive to PLC. The program itself is then going to pass that value to an outgoing mapped program variable called from PLC to drive, and then the output PDO will write the data from this variable all the way back into drive parameter 2022, with the end result that any value put into 2021 will be immediately seen in 2022. So the hardware that I've got, that's actually physically on my desk whilst I'm kind of making this demonstration, I've got a laptop that's got an Ethernet connection to my IPC, PLC controller, whichever back-off hardware that you've got. I've then configured one of the ports on my IPC to be an EtherCAT network port, which is then connected through to the drive via its EtherCAT interface, which in this case is an SI EtherCAT. The drive that I'm using is a UniDrive M. However, the steps that you're going to see in this demonstration work no matter which drive target is that you're using. So it could be a Digitax HD M753, or it could be a Commander C, or any control techniques drive that basically supports an EtherCAT interface. So the first thing that you need to do when you're configuring PDO messages is that you need to know how to convert parameter references. So that's ones in the form of menu and parameter. So 2021 in our case is our parameter reference, and then we have to convert that into an index and a sub-index, because that's how you configure your PDO messages. Okay, so this diagram shows you how the conversion happens. So for parameters that are in this format, just menu and parameter, okay, the first part of the index value, which is a hex value, is fixed. Okay, it's always 20. Okay, the last part of the hex value is actually the menu number, but it has to be converted to a hex value. So 20 as decimal converts to 14 in hex. And finally, the sub-index can be expressed as a straight decimal value, so there's no conversion needed. You simply take the parameter number, which in this case is 21, this end portion of the reference, and then pass it into the sub-index. So if you're having problems doing the conversion between decimal and hex, you can always use the calculator that's in Windows, put it in programmer mode, type in 20 as a decimal value, and then it will actually give you the converted value here, which in this case is 14. Lastly, if you're trying to read from or write to an option slot parameter, so that's parameter references in the form slot and menu and then parameter, okay, 3 parts. This is how that conversion works. Okay, so again, we've got our index value, which is hex. The first part here is fixed. It will always start with 0x2. Then the next character along, that defines the slot number, which will be a number from 1 to 4 depending on the hardware that you've got. The last part again is the menu number with leading 0, so in this case it's menu 02. That would be placed in here, and actually 02 in decimal converts to 02 in hex. They end up being the same, so in this case there's no change. Last of all, the parameter number as a decimal simply gets passed to the sub-index as a decimal. So talking of the slots, so this is how the slot numbers work out depending on drive. So if you've got a Digitax HD, it has 2 external slots that the user can put option modules in, and then a third that's for a factory fit option. So for example, if you've got a Digitax HD M753, that would be an EtherCAT option. If you drive M, it's got 3 user slots, so you can put option modules in these first 3, and then lastly it's got a factory fit option slot, which is number 4, so that might be something like an Ethernet option, for example. Lastly, Commander C. So Commander C doesn't really have an internal factory fit option as such, so that only really has option slot 1. Last thing when you're setting up your PDOs is that you need to know what data type it is that the parameter is, otherwise your mapping simply won't work. Okay, so the data types that you would use are IEC data types, and those are bool, usint, sint, uint, int, udint, and dint. Okay, all these have different bit sizes as shown by this side of the table, but some of those are signed values, like dint is a signed value, and then udint for unsigned dint is not signed. So what we have to do is then go and find out what the data is, or what the data type is for the parameter, and we can go and work that out. So I've got a copy of Connect, and what I've done is I've been through the steps that you'd see in one of the earlier videos where we scan the ADS network, we find the nodes, and we actually create a new project containing them. So my project, it only really contains one node, is this one drive, and then what you'll find is that you'll get a number of things. So in a brand new project, actually, it would probably start at this page, and you probably get the drive configuration. We're interested in this part here, which is the parameter reference. So this is the detailed information on each and every parameter that's in the product, and depending on which mode that it's in. So there we go. So I've opened that. We'll open parameter reference, and you can see the 3 modes that you'll be interested in from a motion perspective are open loop, RFCA, and RFCS. If you're unsure which mode that your drive is in, go back to the drive configuration and read the mode from here. Okay, so I know from my point of view that I've got a servo motor attached. Servo motors use RFCS mode. If you're unsure which mode that you're supposed to be using, click on the little help box, and it actually tells you which motor construction is required with which mode. Okay, so come back to the parameter reference. We'll expand RFCS, and then we'll go and have a look at menu 20, and then I'll click on menu 21, and there we go. It's put that to the top of the page, and what you can see is that it's a 32-bit type. Okay, so that means it's either udint or dint. Now we can narrow it down. We can see that it has a negative minimum number. As soon as you see a negative minimum number, in this case it's very obvious because it's the full signed range, so minus 2.147 billion to 2.147 billion. That's the full 32-bit signed range. You know that this is going to be a dint. And you can see also that 2021 and 2022 are exactly the same data type, so we'll be working with dints in the programming environment. So before I swap to Beckhoff TwinCAT, I will show you one last thing, is that with all of these videos, we've got a getting started guide that runs through all of the content from all of the videos all in one place. So if you don't favour learning from video and you like learning from a book and following it step by step, we've got you covered. This is the purpose of this guide, and you can see we've got a section here that's how to configure PDO mappings and how to pass data between drive parameters and variables using PDOs, which is this video. And there we go. You can see everything detailed for everything that we're actually going to do in this example. Okay, so if that's the way you want to work, there's a link to this in the description for the video. Stop the video, go and grab the link, go and download the document, and work in that way. So, on with the video. So I've got a project here, and in this project I have told my project which controller it is I'm going to use. So I've chosen my target system. I have right-clicked on devices, I've scanned the EtherCAT network, I found the EtherCAT port on my IPC in this case, and then I said scan for boxes. It's scanned for boxes and it's gone and found the drive. Okay, and that's about as much as you need for PDO linking. So what we're going to do to begin with is, as I said at the beginning in the presentation, we need to be able to provide variables in our program for the data from the PDOs to be, linked to. So here's our first variable. It's from drive to PLC. Now, when you're assigning these variables, you have to assign them in such a way that the memory location that they use is in a place where the data linking part of the PDOs can see. Okay, so in order to do that, you have to map them manually into I and Q registers. So there's 3 sets of PLC registers that, you know, they've been in PLCs from at least 30 years, and those are I's, Q's, and M's. In this case, you're only going to be using I's and Q's, so I's are input registers, Q's are output registers. Because this data is coming from the drive to the PLC, it's an input to the PLC, therefore you want to put it in a memory location where it can be seen by the input mappings. So that is %I*. Now the reason why we put asterisks on the end, that tells the system, look, I want it to be mapped into my PLC I registers, but you can make up, you know, you can decide which actual memory location is assigned. I don't care what it is as long as it's in that area so I can link to it. So if you assign it in that way, you'll never have any problems with, you know, more than one thing mapping to the same area in memory. It just goes and sorts it out itself, which is how I would recommend you do it. And then we're going to make that of data type dint, because we just worked out just before that 2021 and 2022 are dint data type. So now we'll do the other one. So this will be the outgoing variable. So I'm going to change that to Q, because Q is outputs, and then I'll rename this. So it'll be from PLC to drive. There we go. So this is incoming from 2021, and then this one will be outgoing to 2022. Okay, now we're going to do the link back. So what we're going to do, our outgoing value, we're going to assign it to our incoming value. There we go. So that's that done. Link data back. So that's as much as we need. So we've got a place for our incoming PDO data to go to, a place for our outgoing PDO data to be read from, and then we've made a link between those things so that the value from 2021 will just appear in 2022. Okay. So at this point we need to build. So I'm going to do that. Build. No errors. Good. So what this does by building at this point, and it is a key step, if you don't build before you begin to set up the PDO mappings and doing the linking, these variables won't appear for you in the link picker. They just won't be there. So don't forget to build at this point. Otherwise, you'll be scratching your head wondering why it is that it's not appeared. So next thing, I've double clicked on drive, process data tab, and then I'm going to click on this one, OX1002. So this is for an NC type axis. This is the PDO mapping that you use as standard. And you can see it's got status, word, and position actual value. So you can tell that those are values that are read from the drive and pulled into TwinCAT. So we want to add something here. So this will be 2021. So I'm going to right click on an empty space, add new item, and now we can add the PDO link to 2021. So I'm going to say, because I can't put decimal points in this, so I'm going to say M20P021. There we go. So I'm going to fill in the hex value, which is 20, and then menu 20 is this last part converted to hex, which comes out as 14. And then I'm just going to enter the parameter number here. So in this case, it's 21. The data type is pre-selected. It must have been the last thing that I did. So that's set as dint 32-bit. So that's as much as we need to do there. Click yes to this message. And there you go. That's our mapping made for incoming data. Now let's go and click on OX1602. And you can see it's control word and target position. So that's something that you would be sending to the product. Okay. So I'm going to select an empty space, right click, add new item. And now let's do the same thing again, but for 2022. So it's M20P022. Same again here, so it's 2014. And then this one, instead of being 21, it's 22. Data type is dint, exactly the same. So there we go. So that's basically the process of making the PDO mapping, but in order to actually functionally do something with it, you have to have something that's in the scope of your program, which is the purpose of the variables that we had in main. So what I'm going to do, I'm going to click on inputs so that we can link up their inputs, and what you can see is that the status word and position values, they have this little box, grey box with an arrow in it. It's quite tiny. So that's showing that not only is there a PDO link to this value, but it's also linked to some data. So this goes off to something within the NC axis itself, because there's an NC axis in this project. There you go, there's the axis. So let's go about and link that. So I usually do it through this view, and I double click on our PDO mapping, and then that gives us the link picker. And here we can see, because we mapped 2021 to an I register, or this value which holds the value from 21 to an I register, it now appears in this list. So I click OK. Now that's mapped. You can see that now it's got a little grey square with an arrow in it indicating that there's a link made. Same again for 2022. Double click, come down, there's our value, click OK, all done. And again, you can see that it's now properly linked. So that's enough to be able to get the program to work. So now I'm going to activate my configuration. So all the setup that I've made here, you click this and then that will be passed into your PLC, IPC, whichever you're using. Give it a minute to sort itself out, and there we go. So that's on. So you can see that the configuration is active. You can see that everything is working okay with this green rotating cog symbol down here. And I'm now going to pass the program into the PLC. So there we go, there's our program running. So I'm going to open up Connect again to do the parameter setting. So I'm going to go parameters, menu 20, and then 2021. If I scroll that up a little bit, there we go. And now I'll just make it so that you can see everything all on the same page. So there we go. At the moment you can see there's nothing in anything, but if I click on here and then put a distinctive number in, so I'll do, I don't know, 10101, something individual. As soon as I press enter on this, you can see that the data has been passed through. So that's the value has been written to 2021, PDO link has read it, it has been passed into from drive to PLC, we've copied it in this line of code back to from PLC to drive, the PDO link has taken that value and then written it back to 2022. So as you can see, this is a fairly simplistic demonstration, but you should be able to repurpose this no matter what parameter it is that you're interested in either reading data from or writing data to from your PLC program. Thanks for watching.